We will discuss the journey of computing, that is from the open systems era to the serverless computing era. Hello, everybody. My name is Sudhir. I'm a backend developer at O4S. I have experience in managing monolith applications, designing and developing microservices and batch jobs. A warm welcome to the talk on serverless computing. I'm delighted to have Shanmukhi Goli on this topic. So in this session, we will discuss the journey of computing, that is from the open systems era to the serverless computing era. We will also look at various serverless services provided by different cloud providers. Goli, can you please give a brief intro about yourself and start the talk?
Yeah. Thank you, Sudhir. Thank you very much. Nice to have you. Thanks for inviting me to this talk. I'm Shanmukhi Goli. I'm the principal architect at O4S. I was having 18 years of experience into the development, and I was architecting many products in the digital space and then telematics. And now my new journey has started with O4S in the supplytics space. That's the small brief introduction about me. Thank you.
Sure. Thanks, Goli. I'll interrupt you if I have any questions during the talk.
Yeah, most definitely. Welcome.
Let's start.
Let me start. Okay. So the discussion that you brought a nice, interesting topic today is that like serverless computing and how it is different from the traditional computing and all the other stuff. So before we get started, let me give like what we're going to cover today. Like we'll see like how the computing evolved over the time, and what is the serverless computing and how it is different from the traditional computing, like where exactly you can apply the serverless computing, the use cases, and like what AWS is offering in the serverless computing space, and what are the other providers in that space, what they are offering. So we'll discuss about some comparisons and other stuff. And then we speak about the security best practices to be taken care when we are doing serverless. And then actually serverless computing also opens up another space, event-driven architecture. Let's see what it is and what benefits or what things it's going to offer. And these are the points that we're going to cover today. Let's get jumped in.
Great.
Like the evolution of computing. If you talk about the evolution of computing, in the very good initial days, we used to have physical servers where we keep them in our local data centers, and then we used to have one application, one server, like that. The advantage of this is that every server is independent, and having problem with one server does not impact the others. But the problem is like we have to invest a lot of investment for procuring the servers, and we may not be using the capacity always 100%, like hardware maintenance, software maintenance. So a lot of overhead was there, but that's how we started initially. And then so a lot of people faced the problem, and we came to a stage where instead of having one application, one server, we wanted to break or split the capacity of a server into the smaller pieces, like the smaller chunks, what we call the virtual machines. And then you deploy the applications on the VMs. So VMs are like a virtual boundaries of the software and the operating system packed together. Here the advantage is that you have to manage very few servers, like compared to the previous generation. Here we are managing less number of servers, and we are utilizing the resources more efficiently. So,
and also during the open systems era, right? We can only deploy one application on each server, so we cannot share the resources between applications. Right.
Now, go ahead. Now with the VMs, advantage of the VM is that you can deploy more than one application, because you are creating a virtual server where you are creating a VM on the hardware with the capacity split between multiple VMs. So the resource utilization is much higher here.
And also there is a overhead for managing the infrastructure, right? We need to provide cooling 24/7 and power
Yeah,
supply and all those things. We need
yeah,
to spend
power.
some we
Yeah,
need to spend a lot of things on opex also.
yes, yes, capex. Yeah. So here, yeah, you are right.
Capex and operation expenses also there, right? Yeah.
You're right. Yeah. So here you need to not to only worry about the servers, you also need to worry about the like providing 24/7 security, 24/7 power. You need to have a dedicated ops team for keeping the servers up and running 24/7. Yeah, like there are few are hidden or invisible problems or challenges that we have to handle. Few are visible challenges that we have to handle. So overall, like the previous two generations of the generations that we're talking have a lot of these kind of issues. Yeah. So the next generation is that the virtual servers in the cloud. So now in the previous two generations, as we discussed, we are managing the servers on the local data centers. Like so you need to worry about the security, physical security, software security, and other stuff. So where the cloud providers changing this game drastically, that you don't have to manage or provision any servers. You just need to tell your capacity, and the cloud providers will give you the capacity in the matter of minutes. So you can convert your capex to the opex. But still, the problem of keeping our like cloud providers will take care of the powering, like cooling solutions, maintenance of the physical servers, and everything will be taken care by the cloud providers. But still, we need to administer the VMs, like provisioning the VMs, hardening the VMs, deploying the software, life cycle of the VMs, and all those things. Still, like the end user or the client has to manage. But these are offering a great flexibility that we don't have to worry about as an end user. We don't have to worry about the hardware or the underlying software operating system kind of thing. So these systems offering a great flexibility of great flexibility over here. But yeah, that's what it is. Then it comes to the containers, the era of containers, where they are changing the computing like from the ground up. Like in the VM, still we have to spin up the EC2 like virtual machines and then manage in the space of containers.
And also in the VM world, right? For each VM, we need to do the patches. That is also kind of headache.
Headache, yeah. You need to do the administration, like hardening the VMs, installing the patches,
and also booting the VM takes a lot of time.
Yes, because it contains all the operating system and everything. And the scaling up, scaling down, or increasing the capacity of your VM is also requires a restart. So still some administration is there. Yeah. With the help of the container, we are now not going the VM route, or where you don't have to pack the software, operating system, and everything. So you just pack your application logic and then give it to your container orchestrator, which will execute the image or which will execute the code inside the container, and then it gives you the output. Here, with the advantage of containers, you are not reserving your capacity per VM or for hardware, for physical.
And also we don't require full-blown OS for each container. There in the VM world, we require full-blown OS for each VM.
Yeah. Yeah, you're right. Yeah. So with the containers, these are like very lightweight packages where you can deploy on any server without creating any boundaries of the VMs, and they execute. And each container, like crashing a container, doesn't again interrupt the other containers or other container instances that are running. And these can be run as many as you want, and you can scale up, scale down very easily without much interaction. And these are very lightweight, so maintenance and all this.
And they can start very quickly.
Very quickly, yeah, because you have a very minimal operating system and just the code that is needed, so you can do. Yes, of course, there are some limitations with the containers, like say in the full-fledged servers, if you want to do some event-driven or like, or if you want to do some housekeeping or maintenance, because you can do a lot, because those comes with a lot of tools and other stuff. But with the containers, because these are comes with the minimal OS, like the feeds, like you need to make sure that you have installed all the required software and packages before we ship the content image, so that they run completely, like they run properly.
Yeah.
Yep. So then it comes to the serverless computing. In the serverless computing, we don't need to package the container, or we don't need to create the VMs. We don't need to worry about the physical servers. You just build your code, and give it to any of the cloud provider like Google, Azure, Lambda function, AWS Lambda functions, Azure functions, or Google functions, anything like you just pack your code, give it to the any of the cloud provider, and the cloud provider will provide you all the underlying infrastructure, creating the image and executing and giving the output. So and the cloud providers will take care of scaling up, scaling down, so we don't have to worry about the capacity problems, and we don't have to worry about the operations management or anything, like as we discussed in the previous sections, like where in the first 2-3 operations we need to still manage the security and other stuff. But here, no need to worry about any of those things. Just give your code, it will be, the cloud provider will execute securely and give it you out, and you just pay for what you used it. Because here we are not provisioning any servers or anything as such. You will be charged at the millisecond billing. At every single millisecond that you use, you are going to be charged. So here, what the advantage is, another upright advantage is that you are converting your capex to the operation expenditure, where you can spend all your money for the operation.
And also, OpEx will be reduced, right? Because we don't need to do patching and all those things.
Yes. So you don't need to have a team or a dedicated IT ops team or DevOps team here, because majority of these functionality provided by the cloud provider. You just need to have a small set of team who can support for deployments and other stuff. But other than that, you don't need to have a full-blown operations team here for managing your infrastructure. Yeah, you're right.
Thanks, Goli. Thanks for the intro on the computing journey. Shall we go further into the serverless computing?
Yeah, definitely. So let's see, like, what is the serverless computing? So if you look at the definition of the serverless, what is serverless and what is serverless computing? So this is the most common definition that we found, or most of the people use is this. Like many conferences, many people generally speak about serverless, and many people use some or all of these words. So we try to bring a common definition here. So the definition, like I stick personally, is that a cloud native platform for short-running stateless applications, computing applications, or compute-required compute-driven applications, or event-driven applications, which scales up, scales down, or scale out instantly and automatically as the demand grows or as the demand shrinks, and then charges for the usage at a millisecond granularity. So if you are using for 2 seconds for running a job, you will just pay for only 2 seconds. If you are using it for 10 seconds, you have to pay for only 10 seconds. So here, it's a cloud native platform, so that we don't need to worry about provisioning or managing any of the servers. And they run very quickly, like they come up very fast in a sub-millisecond latency, they come up. And then they execute in a stateless fashion. So running a previous Lambda instance and the next Lambda instance, or the previous instance of the computation, next run of the computation, doesn't have any connection between them. So they are completely stateless. And when we are building the application, we need to make sure that those stateless thing is maintained and carried out throughout our design. That's the most beautiful thing. And we may have to depend on external services for managing the state, but as such, the serverless doesn't offer you or doesn't guarantee you the stateful thing. So that's the most important thing. And sometimes you can even have this event-driven computing, like say if a file dropped in a S3 could trigger a Lambda, that would be a nice ecosystem of event-driven application. Like instead of you maintaining a monitor and then monitoring S3 bucket for a file to happen or an event to happen, and then triggering the Lambda, you don't need to maintain anything. You just configure your events and you configure your targets, and AWS will provide you all the infrastructure, or the cloud provider will provide you all the infrastructure, and then you just pay for what you use. So you don't need to spend a lot of money, effort on building this base infrastructure. So serverless opens up this nice, beautiful event-driven architecture where you can monitor and trigger and execute the compute in response to an event. Okay, and then
saves developers time.
Yeah, you're right. Yeah, so it scales up, scales down. So as the demand grows, shrinks, or as the capacity, as you need more capacity or less capacity in terms of the size of the container or the size of the execution of the computing, or in terms of number of parallel instances of the compute. You can, like, both vertically and horizontally, you can scale as you can scale up, down as it required. So you don't need to do any housekeeping or anything. As a developer or as a company, you should not be worried about it, and you just pay for what you are using. So there is no point of provision capacity and wasting your finances just because you cannot guess your growth or your demands. So that's what the general definition that I think about it. Yeah.
Okay. Shall we discuss some use cases around serverless computing?
Yeah, most definitely. So so before we jump in, like as I discussed in the previous slide, and before we jump on to the next slide, so I just wanted to give a small caution about what is serverless computing and how should we start thinking. So serverless computing doesn't mean there are no servers. Okay, so there are servers, but we don't maintain
those doesn't appear actually.
Yeah. So they don't appear as to the end user, but they are there. So who will be managing that? That's the cloud provider who is taking care of those things, and we just use them and pay for what you use. So we don't need to worry about hardening those resources, patching those resources, upgrading those resources, nothing like cooling, powering, security, nothing like that. So this is like, generally people say serverless computing means how things happen. No, things that doesn't happen in the air. They happen on the server, but they have to be there instead of we taking
those are like abstract things for us.
Yeah. So, and I want to caution about something like serverless may bring a lot of confusion. So I want to caution about what is serverless, how we generally misconcept or misunderstand. So serverless doesn't mean it's easy to. Okay, serverless doesn't mean it's an application. Serverless doesn't mean that you just give your code, something happen. Okay, so serverless functions should respect SRP, that means single responsibility principle. So every small compute function that you write in the serverless space should be written for only one specific purpose, and every business requirement or every single functionality should go into a separate compute function, so that they can all orchestrated using either an external AWS step function, something like that, where you can orchestrate all of them and execute them in a sequence. Okay, so we should be able to create as many serverless functions as possible, and we should execute them independently or orchestrate them, and then we can do it. So it's here serverless means not the servers, not the applications. It is the orchestration and creation of, or breaking down your business logic into smaller individual chunks and executing them on demand as and when required, and using an external orchestration mechanism to orchestrate and achieve your business functionality. So it can be a small function, or it can be a big list of functions that you have. So depending on your requirement, so you choose like how you want to execute. You want to execute as a single function, or you want to orchestrate them. So here the concept of understanding what is serverless and how we should orchestrate or how we should be doing them is more important. So generally, if you don't get that idea right, then like it may give some wrong opinion. So I just wanted to use this slide and previous slide to clarify that.
Thanks for clarifying.
Yeah, so the capabilities of the serverless platform, that the question that you asked, so you can keep your compute logic in the cloud. So we are not paying, or we are not managing any infrastructure, and you are using like if there are more functions or more compute you have, like as we explained earlier, you can have as many functions or as code compute that you have. You can orchestrate them and manage the state using external resources rather than the functions. So the functions itself will follow the single responsibility principle, while you are taking care, or you are building a orchestration layer on top of that, so that everything or all the logic can be managed independently. Okay, so and you can build responsive data sources, like as the demand grows and shrinks, you can plan your data resources or your resources in response to the growing demand, and your applications become more responsive because everything is elastic in the serverless space, right? So you can have more responsive data stores and more responsive applications, so your system become your starts behaving like as if it's instantaneous. Okay, and this cloud platform offers you a great flexibility of tools in the serverless space, especially. So it gives you like application modeling and framework, where you can, like, say for example, if you take AWS offers something called SAM, small application modeling, small application deployments. So where it's a framework where you can define, build, and deploy your serverless computing with the help of easy to manage scripts, right? So yeah, because of this, your time, you can spend a lot of time on building these applications rather than worrying about how to deploy, how to manage, how to model, and all those things, right? So you are abstracting out all other remaining stuff from your business logic. So just concentrate on your business logic, rest is taken care. Then integration library. So integration library here is like, say you want to use other serverless functionality on the cloud. Like say you are building a Lambda and you want to use an SQS for your message source or as your message destination. You can simply use the ecosystem of the services for building your integration for the integrating with other services, and you can simply use it. So you don't need to spend a lot of effort for building that ecosystem. So with the help of integration library, you can do a lot of integration with other ecosystems.
So SDKs are provided for each service, so we just need to use them.
Yeah, like for most of the programming languages, for most of the services, the SDKs are provided by these cloud providers. Yeah, you are right. So that's the integration library. So you'll get a lot of integration libraries, and you have a AWS marketplace where you can, if AWS doesn't offer you certain functionalities, you can still go and look at the marketplace and purchase them, or if they are open source, use them and get your stuff done.
Great.
Right? Yeah. Developer ecosystem, like many of these cloud providers offer you a lot of tooling that is required to make your life easier. For example, as we discussed in the previous section, like integration library. So there is an SDK for every service that you want to use on the AWS, right? So there will be more than one way of integrating them. And a lot of these IDEs these days support out-of-the-box support for the AWS SDE integration. Like you get a lot of IntelliSense and everything. So your development becomes very easier, right? So reliability and performance, because these are maintained by the cloud, and because they have a lot of resources, they have a lot of expertise managing this. So the underlying hardware is well taken care by the cloud provider. If there is some hardware is performing bad or it's not up to the standard or nearing its retirement age, so without worrying about the user, like the cloud provider, without any disturbance, they simply swap out the badly performing hardware or anything. So we can guarantee, or we can completely rely on the performance and reliability of our executions. And the third thing, or the last but not least, is the global scale and reach. So because here the demand is up and down, scaled up, scaled down instantaneously, you can execute these functions or these compute anywhere in the world, like as your underlying cloud. The only limitation is that your underlying cloud provider. If the cloud provider has a physical presence on a particular region, you can simply deploy it with a click of a button, and then immediately it's available to your customers.
Okay.
Right?
So if you need to use a particular service, we need to check whether that service is available on that region or not.
Yeah, of course. Yeah. Most of the common services these days are available, but yeah, like some new services or experimental services, or maybe some, because of the regional restrictions, some services may not be available. So yeah, there is a limitation, but when you speak most generally, like most of these commonly used services are available. So in most of the regions. So yeah, but if you keep the odds or the small portion of the odds outside, but reaching to the global scale and reach is like a click of a button. So generally, when we talk about it, it's very easy. That's the good point of it. Yeah, while it is also important, we should be sure that those services are available in that region before we go and commit. But yeah, but if they're available, it's just a click of a button.
Yeah.
And the security and access control, yes, as we discussed in the first slide with the physical servers or the VMs and containers, still we need to worry about hardening them, physically secure them, logically securing them, installing the patches and all those things. With the serverless, you just need to worry about your computer, your business functionality. Rest is taken care by the cloud provider, and they follow best industry standards for making sure that the underlying infrastructure is secure and do like ISO standards or the any other standard like that they need. So like the AWS has resources or the Azure has resources where they can be specialized in that security and access control.
Great. So with serverless computing, we just need to focus on developing the applications, not on managing them, scaling them, and look for availability of the application and all those things.
Yeah, you are right. You don't need to worry about the ecosystem. You just need to worry about your business logic. How quickly you can be into your business, like especially the startups that are coming up these days, like they have a business idea and they need some kind of platform.
They can quickly put that idea into the
execution and then try it out. So with like especially the serverless computing makes that thing really easy, because as we saw, you don't need to worry about any of the ecosystem, just concentrate on the logic. Yes.
Okay. Can we look at the different cloud providers and what serverless options are available?
Oh yeah, definitely. Before we jump in, let's see what are the common use cases, and then
Sure.
We can go about the cloud providers and all those things, like where you can use the serverless computing, like okay, and what are the use cases. So it comes like this list is not infinite or finite. The list is endless, but I try to capture some of the most common use cases. You can use it pretty much everywhere. Okay, and the list is growing, so I don't want to say this is the infinite list, but this is just a finite list. So you can use web applications. Like say you want to host a static website on a AngularJS, React.js application on an S3, and you can start serving your application, and rest of the functionality you can build elsewhere. Or like you can use dynamic web applications. You can use CDN for distributing your content, where you don't have to manage any physical servers. The underlying cloud provider will make sure that the content is distributed geographically and available. And edge computation, edge replication, like Lambda, like say you want to execute some compute in response to a CDN, even like somebody is trying to download or stream a live match, something like that. You can actually deploy a Lambda at the edge location where it can be executed in response to a CDN, something like that. So the ecosystem is very big. You can deploy WAF, web application firewall, for making sure that for preventing any DDoS or man of the middle attacks or anything. Like you can deploy a lot of things at a click of a button. So in the web space, the cloud providers providing a big list of applications where you can use them. And then big data, so you can use like Kinesis or Kinesis Firehose or anything, like where you have a lot of data that is streaming into your system, like say market, like stock market events that are coming into your system, and you want to build a analytics platform on top of that, or anything, like you want to take all the credit cards data streaming into your system, like people are using your credit card globally, and you want to build a pattern seed for detecting any threats or anything. So you have something called big data, where you can use Elastic MapReduce or Glue or Athena for building these kind of ingesting the data into your system, and then building those models and analyzing, and then storing the data. So you can use Athena, Glue, EMR, or you can use batch and offline, like where you have lots of data that you want to process, but where it doesn't require any manual intervention or anything. You can use Fargate, AWS Batch. You can use recognition for video processing. Like say you have a supermarket or a shopping complex where a lot of people are entering and leaving, and you want to do the sentiment analysis or people's mood analysis or anything like willingness to buy, or like all those things. You can actually stream the data and process it using the recognition, and then you can build a lot of analytics out of it. And you have CloudWatch for logging and monitoring, Kinesis Firehose, Kinesis Streams for the data streaming and processing, and you have Event Bridge for triggering the events and monitoring, like CloudTrail and GuardDuty for monitoring, alerting of your infrastructure. If you deploy a Lambda function and that Lambda function is being compromised or something happen, you can simply configure your CloudTrail to see like who are the people touching your infrastructure and what changes they are making. And if those changes are not in line with what you are anticipating, then you can simply trigger an alert so that you can quickly take a look at and monitor and fix it. Because with the rise of the blockchain technology and a lot of people not configuring their infrastructure safely, these people are using our machines to mint the currencies, right? Like the coins. So so you get the help of CloudTrail, GuardDuty, and these kind of tools. You can build monitoring and alerting and and quickly find out those kind of chaos and then fix them. Okay.
Okay. So all these services are from AWS or from different cloud providers?
Mostly here, I mentioned the AWS related services because AWS has the biggest ecosystem than compared to any other cloud provider except the most common ones. So I am putting here mostly from the AWS. Yeah.
So we don't need to put, and also we don't need to put any money upfront, right?
No, you don't need to pay anything. You just that's the advantage and beauty of the cloud computing, right? Just pay for what you use. So you pay after you use, not before.
I mean, yeah.
So the backends and the chatbots, like the chatbots, you can build using the Alexa, or you can use it Lex and Poly, or you can use API gateways, IoTs. Greengrass, AWS has a Greengrass for building the IoT applications and all those things. Apps and services, Lambda and Lambda Edge, Lambda Snowmobile Edge, a lot of things were there. So AWS is going to give a lot of ecosystem compared to any other cloud provider for managing and building the serverless space. So now coming to the point that you are asking, hey, what are all the leaders in the market and what services they are offering? Yeah. So thanks for asking that question. So I just try to summarize, and this is not a full list though. Okay, I want to just cautious about it, and this list may be outdated too because every day a lot and many services are being built and provided by these cloud providers. This list is not infinite or not finite, so this might be a little outdated too. So, but I just try to cover some of the basic services that are offered by each cloud provider. So obviously AWS is the market leader. Azure is just behind the AWS.
Yeah, just trying to catch up.
Yeah, so they're just competing each other. Like many times they go head to head, and then Google is catching, but still it's there in the race, but it's lagging still behind. For some reasons we don't know, but yeah, so obviously AWS is the leader. So in the compute space, in the serverless, AWS offers the Lambda. That's the most popular thing, and Azure has something called functions, and Google has something else functions. So this is the most common thing. Of course, AWS has Lightsail, AWS has Fargate, AWS has a lot of
these are like similar kind of services provided by each provider, right?
Yeah, each provider. Yeah. So when it comes to the Lambda, AWS Lambda, there is a time limit of 15 minutes. And Azure doesn't have a time limitation on executing these functions, whereas Google also doesn't have. We need to. I'm not sure like what Google is managing because I have never used it, but at least what I know is AWS function, Azure functions doesn't have any time limitation. That's what I read. But yeah, definitely AWS has 15 minutes time limit. So anything that you are writing should be finishing in 15 minutes. Otherwise, it will be 10.
If something is taking more time, I mean, like 30 minutes or something like that, we should not go for AWS Lambda.
No. Lambda functions are writing a small business logic rather than a whole business logic. So you should make sure that it will execute in a smallest possible time, and then it gets terminated.
If it is a long running task, then we need to look for other service provided by
EKS, Kubernetes cluster, anything that you want to use a regular compute rather than Lambda. Yeah, Lambdas are not meant for doing those kind of things. This is like Lambda is for quickly coming up and executing a task and dying. Like say processing an event, like a file drop happened in S3 and you want to quickly process that event and then quickly die or kill your container, just go for it. Yeah, don't program for long running things.
Got it.
Yeah. So when it comes to the storage, AWS offers S3, DynamoDB, Aurora Serverless, lot of things, where S3 is a static file store or object store where you can put files or anything. DynamoDB is for storing your document key value store. So you put a key and then you can put a document. The document can be a JSON document or anything. It can be any complex. It's a key value based store. And when it comes to the RDS or RDBMS, AWS offers Aurora Serverless, which recently AWS is pushing a lot, where you can have multi-region, multi-master kind of thing, and you pay just for what you use. Similarly, Azure has storage for storing the objects, and static objects are the objects, and they have a document DB for the key value store. Similarly, Google has a storage, and they have data store for managing the storage. That's the very high level. Like
are they using storage for the Google Drive application?
Yeah, underlying, like, yes. Even like if you look at the OneDrive from the Azure, they use the storage for providing the infrastructure, right? So even like if you look at the Dropbox or anything, most popular cloud drive providers, actually they built initially on the S3 and then later they moved away. So yeah, so like you can build very interesting applications and business out of these serverless models. Yes, so they are actually using their underlying infrastructure to do this. Yes. And then gateways, API gateway and endpoints. These are offered like for controlling the traffic that comes and goes out of your network or infrastructure. So messaging, inter-process messaging, or anything, like you can use SNS, SQS, notification hub, service bus, or the pub sub. So AWS has a very popular concept. Like if you want to have a pub sub model, you can go for SQS. If you want to have a fan out model, you can go for SNS. So that's very interesting. So Azure has something similar like notification hub or service bus. So notification hub is for fan out, and service bus is again for delivering the messages from point A to point B or between the services. So Google also has pub sub model where you can use it for both fan out and as well as for this thing. And there were a few other interesting tools like IAM. In the AWS IAM, you can identity and access management. You can pretty much secure your applications with the policies and roles. Like you can lock down who can do what, which application can access what operations are the what other services, and how much they can do. So you can pretty much build very complex, very detailed policies. And a CloudWatch, you can do all your logging and monitoring into your CloudWatch, like especially the events that are emitted by your serverless infrastructure or serverless applications can go into the CloudWatch, and it's a one-stop shop or place where you can go and dig through troubleshooting or digging through what is happening in the system. Cloudfront, as we told, it's for distributing your content like CDN. It's the CDN offering from the AWS. So similarly, Azure and Google also has. So for logging, they have App Insights and CloudWatch, IAM, AAD, those are the things. Cognito is a specific thing where here it like AWS is trying to bridge the gap of providing authentication, especially not the authorization services, authorization as a service. So AWS built Cognito for solving that problem, and it is the actual competitor of Auth0 or other competitors where you can build out of the box authentication frameworks or authentication into many of your applications.
Great to know all these services.
Yeah.
Yeah.
This is, though this list is not finite, like complete. So these are only just a few. Don't take this as a complete list.
Okay. So AWS is the market leader, right, in the public cloud space. Can we see what are other serverless options are there in the AWS?
Yeah, most definitely. So the ecosystem, if you take a look at it, this is the list I try to build quickly. But this is not as I told, this is not the complete list. There might be more, there might be less. A lot of things might be happening, but yeah. So if you look at here in the compute space, we have Lambda, Lambda at Edge, Fargate. If you look at the storage, we have S3 EFS. As I told, DynamoDB and serverless, Aurora serverless in the previous slide. Integrations, you have API gateway, interprocess messaging, SQS, SNS. If you want to orchestrate or do some orchestrated operations, you have step functions for analytics and streaming and other. You have Kinesis Streams, Kinesis Firehose, Glue, Athena. Actually, AWS recently launched a complete suite of developer tools where it provides a in-browser Cloud9 IDE, and once you finish your code, you can commit your code into the code commit using the code commit, and then code commit will cause the code build. Code build will do the code deploy, and then using the code pipeline. So AWS has released a complete developer tools for building, creating, building, deploying, and managing the infrastructure. And you can use X-Ray, CloudWatch, CloudGuard, GuardDuty, actually not CloudGuard, GuardDuty and CloudTrail and all these things for monitoring your infrastructure. For security, you have KMS, Key Management System, Secrets Manager for storing all the application-specific usernames, passwords, or any other secure information. Param Store for managing the parameters which are specific to the environment or application-specific. Cloud HSM, cloud-based hardware security module for keeping your most secure information that you don't want to compromise or protect the data. You have SageMaker, Lex, Poly, Recognition, Extract for the AML. So AWS is launching more and more resources day and day. So this is some of the most popular lists that most of the us use day to day. So yeah, this list might be changing, but yeah, this is.
I think we can deploy our application entirely on serverless. I think there is an option for each use case in our application.
Yes, yeah. You can do pretty much everything without worrying about anything.
Let's go ahead. I just want to know something related to security best practices around when we are using the serverless services.
Yeah, most definitely. Thanks, Sudhir, for asking that question. Actually, we so far we saw only the bright side of the serverless, and unless until we safely do the security of it, it becomes a nightmare. So when it comes to the serverless, you are putting all your data and your infrastructure, everything on the cloud. So if we are not safeguarding it properly, the data and the infrastructure, so people can simply attack our system. If you recently looked at Facebook, right? Facebook kept all their usernames, passwords, and everything in S3 in a plain unencrypted format, and hackers swept into it, and then they got access to the entire list of things, right? So cloud is offering a great flexibility, but that doesn't mean that we need to be worried about the data security. So data security, we need to always keep the data safe, encrypted at the rest and during the transit. That is more important. Like at the rest, when you store it on something on the cloud, or when you are transmitting the data between your client and server application, then you need to store. So data encryption and secure transcription. So data encryption, always use some cloud provided services like KMS or anything for encrypting the data during at the rest. And use TLS, SSL for safely transmitting your data between the client and server applications so that it is not available to the hackers. And also, it is the equal responsibility of the customer. Like while AWS is providing the physical security of the servers, power and cooling and other solutions, it is also important that the end users have equal responsibility to securing and safeguarding their infrastructure and their data. So AWS doesn't provide that service. AWS provide required services, but it is up to us how we want to use it. If we don't use it, then if something happens, it is the responsibility of the customer. So AWS, like that's why we call it the shared responsibility model. AWS shares some responsibility and the customer has to share some responsibility. So infrastructure security, for example, we need to lock down all our ingress egress rules, security groups, NACLs, NATs, everything. Like we need to safely or thoroughly assess what is the requirement, what ports we want to use, what ports we don't want to use. Lock down your ports, ingress ports, egress ports, and use VPC endpoints wherever possible for safely transmitting data between the services rather than entering into the internet and leaving. Like say, when you are trying to read a file within your VPC from an S3, because S3 is a global service, by generally the data from the S3 enters into the internet and then leaves the AWS infrastructure and then enters in again over the internet and then comes back to your VPC. So to avoid all that, you can use VPC endpoints where the data doesn't leave over your intranet or AWS infrastructure and enter the internet and then comes back to you. So it reduces a lot of latencies, frictions, and a lot of security issues. So use VPC endpoints wherever they are supported. And also, as I told, you always make sure that the latest patches of the software and everything is installed so that our infrastructure is safe. So it is equally important that in the shared responsibility model, AWS takes care of AWS part. As the customer, we should take care of our part in terms of both data security and infrastructure security.
Sure. Before closing the session, can we see any downsides are there in the serverless computing?
Yeah, so the first things first, the downsides is that because you are locking yourself to the vendor, because you are tightly integrating and trying to use the vendor specific services, so vendor locking happens. And second thing is that if we do not carefully use the serverless scaling, auto scaling, eventually you may end up paying so much of bill. Like we should carefully assess and carefully define our scale in, scale out, scale up, scale down for limitations. If you don't do that, you may end up paying so much of money. Of course, AWS gives us a lot of volumetric discounts, but those discounts are not actually covering your improper configuration of those things. Okay, and then troubleshooting and the deployments. Logging and monitoring, especially in the serverless computing, is a nightmare because these are stateless things, right? Stateless computations and stateless events. If something really goes wrong, if you don't have proper logging and monitoring or troubleshooting not configured, then it becomes a nightmare for tracing out what is happening. And also the infrastructure management, because here these are deployed independently. If you do not have proper IAC, infrastructure as code, or some better disciplines like cloud, or like Terraform, or like these kind of like IAC templates, or if you don't follow any automated processes, the deployments and all these things becomes a nightmare. So those are some of the limitations, some of the advantages. Like the advantages, like you get a lot of flexibility, but at the same time, they comes with a lot of limitations and dangers that we should be careful of.
Thanks, Goli. You have covered a lot of things.
Yeah, so I want to cover before we go event-driven architecture. This serverless opens up, like initially in the first few slides, we covered something called serverless event-driven architecture, or like say a Lambda can be triggered in response to a file drop in S3. So this serverless opens up a new world of opportunities where you can trigger your compute, or you can trigger any other operations in the serverless space based on an event, in response to an event that is happening in the ecosystem. For example, you have an S3 bucket and somebody uploaded a file into that S3 bucket. The moment it is uploaded, you want to process that file and take some action on the other hand. You can simply configure an alert or monitor in the S3 bucket. And then when something happens to that, an event can be triggered, and that event can trigger your Lambda or your batch or anything, and then that compute can receive the information that caused the event, and then you can do a lot of processing, and you can invoke a big list of or big chain of events that can happen. So these are there can be scheduled events or activity-based events. Scheduled event in the sense, like say you want to execute a Lambda every 5 minutes, and you want to process some information in your system and then emit out the data. So you can schedule that based on the cron expressions, or activity-based, event-based. So event-based in the sense a file drop or a message dropped into an SQS, or a file dropped into an S3, or a message dropped into an SNS. anything like you can invoke a compute or serverless functions in response to some other things are happening in the ecosystem. Okay, so these are opening a new world of opportunities here. This is a different use case that is getting more popular and more and more popular recently. But yeah, we covered a lot. Yeah, this is another interesting topic that I wanted to bring in. Yes.
Thanks for sharing it.
Yeah. So thanks, Sudhir. Yeah. So
yeah, thank you all for joining the session. Great to have all the discussion around serverless computing.
Yep, definitely. And also, I just wanted to, before we drop, I just wanted to say something. Like, say, we would be dropping episodes every week on the most interesting topics or the most happening topics in the industry. So be sure that you are all subscribed to this channel, and that way you get notified every time you receive a new episode or we post a new episode. Also, if any of you guys, any of the audience have any questions, please drop a message on the comment section, and we will be responding to those questions as and when we receive those notifications. Yeah. Thanks everyone.